Hello everyone, I am Jasmine P. Lauglaug and I will be your company towards your review and licensure examination for teachers in the future, especially on mathematics majorship. So I am with my partner, Mr. Mark Manlunas. He will continue this review. So for my part, we will be tackling um, two types, mathematical theories and concept, as well as the problem solving and processes. Okay, without further ado, I welcome you all in this review. Okay, let's start. For number one, what ancient civilization is credited with developing the concept of zero as a number? Is it the Egyptians, Greeks, Romans, Indians, or Babylonians? And the answer is Indians. So, um, in Egyptians, they introduced the quadratic equations, geometry, arithmetic, calendars, enumeration, and volume. So basically, they did not introduce zero. Wait. For the Greeks or Greece, however, they introduced the geometry, algebra, mathematical proofs, number theory, mathematical analysis, and trigonometry. Romans, on the other hand, created a number system based on symbols such as I, V, X, L, C, and C, D, and M, which represented the numbers 1, 5, 20, 50, 100, 500, and 1000 respectively. The Babylonians also introduces the sexagesimal system, wherein it used a base of 60 system, which is more advanced than the base 10 system used today. They also introduced the place value system, where digits written to the left represented larger values. The Pythagorean theorem also originated in the Babylonians, which was later formalized by Pythagoras. So why? Now, if you are going to use the elimination method, Egyptians, Greek, Romans, and Babylonians will be eliminated from the choices. So basically, it will give us the answer Indians. But it still has a enough explanation. So around 3 BC, the first zero was observed in Mesopotamia. Around 4 AD, the Mayans independently developed it. Later, around the middle of the 5th century, it was developed in India. By the end of the 7th century, it had spread to Cambodia, and by the end of the 8th century, it had reached China and the Islamic nations. In the 12th century, zero made its way to Western Europe. So basically, the credited Asian civilization for this is the Indians, because they are the ones who developed it. So let's have number two. What ancient mathematical text is known for containing the earliest known statement of the Pythagorean theorem? So is it the Euclid's Elements, Rent Mathematical Papyrus, Sulba Sutras, the 9 chapters on the mathematical art, or the Liber Abacus? So the answer is Sulba Sutras. So, what is the earliest statement of the Pythagorean theorem, by the way? So it is, the theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So Sulba Sutras is a Vedic text that contains geometrical rules and theorems, including the Pythagorean theorem. The theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is why a squared plus b squared is equals to c squared. The Sulba Sutras are appendices to religious texts that provide rules for constructing altars of various shapes. They are construction manuals for geometric shapes, and the sutras contain many examples of Pythagorean triples. So how about Euclid's elements? So Euclid's proof of the Pythagorean theorem was unique. So it contains the proof of the Pythagorean theorem and its approach and organization. He proved the theorem by showing that the areas of the smaller squares add to equal to the area of the larger square. So that is what the Euclid's element states. In Rind Mathematical Papyrus, it is an Egyptian papyrus that dates back to around 1800 BCE. It contains Pythagorean triples, which suggests that the Pythagorean theorem was known in ancient Egypt and Babylon. So it does not state the known statement of the Pythagorean theorem. On the other hand, the 9 chapters on the mathematical art compiled in China in the 1st century CE. This treatise includes problems that involving finding the length of a right triangle side when the other two sides are known. It also includes Pythagorean triples and mentions right triangles. So for Liber Abaci, the Liber Abaci or the Book of Calculation, it was a 1202 Latin work on arithmetic by Leonardo of Pisa. It is known as Fibonacci. It is primarily famous for introducing the both base 10 positional notation and the symbols known as Arabic numerals in Europe. So basically, Sulba Sutras is the one that contains the earliest known statement of the Pythagorean theorem. Number 3. Which mathematician is known for his contribution to the development of calculus alongside Isaac Newton? Is it René Descartes, Gottfried Wilhelm Leibniz, Blaise Pascal, Carl Friedrich Gauss, Pierre Simon Laplace? Okay. So who is with Isaac Newton in developing the calculus? So it is Gottfried Wilhelm Leibniz. So he is the mathematician who is known for his contributions to the development of calculus alongside Newton. So in calculus, Leibniz and Newton are both known as the creators of calculus, which is the study of continuous change. They independently developed differentiation and integration, which are fundamental techniques for mathematicians and scientists. For notations, Leibniz also used in much of the calculation that is taught today. For example, he introduced the integral sign, which is the question mark. He introduced that one. Other contributions of Leibniz is that he developed the law of continuity and transcendental law of homogeneity, which were not used in the mathematics until the 20th century. He also invented the Leibniz wheel, a mechanical calculator that was used until the mid-1970s. Leibniz is also considered by many to be the first computer scientist and information theorist. So for René Descartes, Descartes is the namesake of the Cartesian coordinate system. Descartes used the coordinate plane to trace motion with respect to time. This was critical for Newton to develop calculus, which is basically the analytic geometry of Descartes with the philosophy of Exodus. Blaise Pascal, on the other hand, made many contributions to mathematics also, including the foundations of probability theory, but it did not contribute directly to the development of calculus. He also introduced the Pascal's triangle, a triangular array of numbers that is used in probability theory and has many other mathematical applications. Theory of probability is also invented with Fermat, wherein this branch of mathematics is used by insurers and actuaries to calculate the risk. Carl Friedrich Gauss independently discovered the Bode's law, the binomial theorem, and the arithmetic geometric mean, as well as the law of quadratic reciprocity and the prime number theorem. So that is what he invented. Pierre-Simon Laplace contributed to the development of calculus, including the translating classical mechanics to calculus. Laplace's work translated the geometric study of classical mechanics into calculus base 1, which opened up a wider range of problems. For formulating Laplace equation, which is used in many branches of mathematical physics. So that is what Pierre-Simon Laplace. So basically, Gottfried Wilhelm Leibniz is the one with Isaac Newton in developing the calculus. Question number 4. Which mathematician's work laid the foundation for the coordinate system used in graphing equations today? So who is the one who invented the coordinate system? Is it Blaise Pascal, René Descartes, Isaac Newton, Carl Friedrich Gauss, or Euclid? So we already discussed the contributions of Blaise Pascal, Carl Friedrich Gauss, as well as Euclid, or we'll be tackling again Euclid. So René Descartes is the one who invented the Cartesian coordinate system. It bears his name in 1637. It is sometimes called the rectangular coordinate system because the grid is made of squares. The Cartesian or rectangular coordinate system consists of a horizontal x-axis and a vertical y-axis. That is what we are using nowadays. So Blaise Pascal, we already discussed it already. He invented the Pascal's triangle and the theory of probability. For Isaac Newton, of course, a while ago we have mentioned that he developed the calculus alongside with Gottfried. So we also introduced the binomial theorem as well as the differential and integral calculus. For Euclid, he introduced or invented the Euclid's elements. He is also known as the father of geometry. Number 5. Which Asian civilization is known for using a complex system of symbols to represent large numbers, influencing modern number theory? So is it the Romans, Egyptians, Mayans, Greeks, or Chinese? So the answer is Mayans. So we will know later on why. So here, the Asian civilization known for using a complex system is the Mayans. So for Egyptians or Romans, let's have Romans first. Here, so you can see this is the number system of the Romans. It is called the Roman numerals, which we are still using for today, as of today. But this is not what we use in the modern number theory. Next is the Egyptians. We have here the Egyptian numerical hieroglyphs. The Egyptians developed a system of numerals that combine symbols to represent powers of 10. Other hieroglyphic numerals were used for both practical and religious purposes. Although their system was not a positional numeral system like the one we use today, it greatly influenced later developments in mathematics and number theory, especially in the way numbers could be represented and manipulated for purposes like architecture, trade, and astronomy. So for the Greeks, this is the numerical symbols of the Greeks, or in Greece. We have the Chinese, and lastly the Mayans. So we are using this today in our modern number theory? Number 6. Which mathematician is famous for his work on the properties of prime numbers and developed the famous last theorem? So you developed the famous last theorem. Is it Carl Friedrich Gauss, Pierre de Fermat, Évariste Galois, Leonhard Euler, Johann Bernoulli? It is Pierre de Fermat. He is known for his work in number theory, including the Fermat's last theorem, and for his contributions to the foundations of calculus. He also considered the founder of modern number theory. Pierre de Fermat's life, mathematical discoveries, and lesson summary. So Carl Friedrich Gauss. We already know what he discovered the Bode's law, binomial theorem, arithmetic geometric mean, law of quadratic reciprocities, prime number theorem. Évariste Galois, he introduced the abstract algebra, Galois theory, and the solutions by radicals. Leonhard Euler introduced the functional notation f of x, trigonometric functions just like sine, cosine, and tangent, and he also invented the Euler's formula. Pierre de Fermat introduced the Fermat's last theorem. He also take part in the foundations of calculus, as well as he is the founder of modern number theory. So it is Pierre de Fermat. Number 7. Who wrote the influential book Principia Mathematica, which laid the foundations of classical mechanics? Is it Galileo Galilei, Isaac Newton, Johannes Kepler, Blaise Pascal, Albert Einstein? So, it is Isaac Newton. Galileo Galilei, he introduced the areas of the smaller squares add to equal the area of the larger squares. Johannes Kepler, the Astronomia Nova and New Astronomy, he wrote that one. The Epitome Astronomiae, Harmonies Mundi. Blaise Pascal has the straight do triangle arithmetic. Wait for a while. So it is his most influential book, which is also known as the Pascal's Triangle. Pascal's Triangle is a triangular arrangement of numbers where each number is the sum of the two numbers directly above it. So Pascal's book described the triangle as a convenient way to represent binomial coefficients. Albert Einstein, on the other hand, it has the greatest contribution to mathematics with his Einstein's field equations, wherein these are equations that show how stress energy influences movement in space and time. These equations are part of the study of calculus and geometry. Question number 8. What is the first step in the mathematical investigation? A. Collecting data. B. Defining the problem. C. Formulating a hypothesis. D. Testing solutions. Or E. Analyzing results. So the correct answer is B. Defining the problem. In any mathematical investigation, the first step is to define the problem. This involves clearly understanding and stating the questions or problem you are trying to solve, as well as identifying the assumptions, variables, and constraints involved. Only once the problem is well defined can you proceed with the next steps, such as formulating hypotheses, collecting data, or testing potential solutions. The other options typically come after the problem has been clearly defined. So we have the collecting data. This comes after the problem is defined, especially if the problem involves empirical investigation. For formulating a hypothesis, this part of the process that follows defining the problem, where you make an educated guess about how things might work. For the testing solutions, after forming a hypothesis, testing various solutions would be the next step. And analyzing results, this comes after you have collected data and tested your hypothesis or solutions. Therefore, the first step in a mathematical investigation is to define the problem. Number 9. Which of the following best describes a mathematical model? A physical representation of a concept. B. A set of observations about data. C. An abstract mathematical representation of a system. D. A computer program. Or E. A statistical survey. So a mathematical model is a quantitative description of a system that uses mathematical language and concepts to represent a concrete system. Mathematical models are used in many fields, including the natural sciences, engineering, and social sciences. They can be used to explain a system, study the effects of different components, make predictions about behavior, solve complex problems, and answer questions. Mathematical models can be used to represent a system that change continuously over time, or systems that are represented as snapshots at specific times. For example, a population that is growing or diminishing over time would be represented by a continuous model, while a population's age, sex, class structure at a specific time would be represented by a discrete model. So, based on the given choices, the correct answer would be letter C, an abstract mathematical representation of a system. So let's move to number 10. In the context of mathematical modeling, what does validation refers to? So is it A, proving a model is mathematically correct? Or B, ensuring whether or not the quantity of interest for a model is within some tolerance? C, confirming the originality of a model. D, comparing the model to similar ones. Or E, simplifying complex equations. So for number 10, validation means letter B. The correct answer is letter B, ensuring whether or not the quantity of interest for a model is within some tolerance. So why? So in the context of mathematical modeling, validation always refers to the process of determining whether the model accurately represents the real-world system or phenomenon it is intended to describe. Specifically, it involves checking whether the model's predictions are reasonable and whether the quantities of interest fall within an acceptable range or tolerance when compared to observed or experimental data. This ensures also that the model can be relied upon for decision-making or further analysis. So why the other options are less appropriate? So let's have letter A, proving a model is mathematically correct. So this is related to verification, not validation. So verification involves checking whether the model has been formulated correctly from a mathematical point of view, whether the model is logically consistent and its mathematical structure is sound. So let's have letter C, confirming the originality of a model. So why this option is less appropriate? So letter C refers to checking if the model is unique or new, which is not the purpose of validation. Letter D, comparing the model to similar ones. While comparing models can be part of the broader process of the model evaluation or selection, it is not validation. Because validation focuses on testing the model's accuracy against real-world data or known outcomes, not simply comparing it to the other models. So last is letter E, simplifying complex equations. So this is an aspect of model reduction or model simplification, which is a different process. While simplifying a model might be necessary to make it more computationally feasible or understandable, it is not the same as validation, which focuses on assessing the model's ability to represent real-world data accurately. So therefore, validation is a process of ensuring that the model's predictions are accurate and fall within an acceptable tolerance when compared to real-world data or observations. It checks how well the model represents reality in practice, not just whether it's mathematically correct or original. So that's validation. Number 11. In a mathematical model predicting traffic flow, which of the following variables would most likely need to be adjusted to account for a sudden road closure? Is it A. Average vehicle speed, B. Number of traffic signals, C. Traffic density in surrounding areas, D. Road length, or E. Time of the day? So for number 11, the correct answer would be letter C. Traffic density in surrounding areas. So why? When modeling traffic flow, a sudden road closure would most directly affect the flow of traffic by causing vehicles to be rerouted or forced to take alternate paths. Therefore, the traffic density in surrounding areas, which is the option C, is the variable that would need to be adjusted. With the closure of one road, traffic would likely accumulate in nearby roads as drivers look for alternative routes, causing an increase in density in those surrounding areas. For number 12, which mathematical technique is often used for optimizing a solution in modeling? Is it linear regression, simultaneous equations, calculus of variations, D-dimensional analysis, or factorization? So the correct answer for this one is the calculus of variations, or option C. So in mathematical modeling, calculus of variation is a technique often used to optimize a solution. In optimizing system like minimizing the cost of materials or optimizing a path for traffic flow, calculus for variations allows you to find the optimal function that satisfies certain boundaries, conditions, and constraints. So therefore, the calculus of variations, option C, is the most appropriate mathematical technique for optimizing a solution in modeling. Let's move for number 13. The question is, which of the following is an example of continuous mathematical model? So letter A, the population growth of animals in a closed habitat. B, the number of cars sold per month at a dealership. C, the temperature variation over the course of a day. D, the number of people attending a concert. Or E, the outcome of a series of coin flips. So the answer is letter C, the temperature variation over the course of a day. So why? A continuous mathematical model describes phenomena that change smoothly and can take on any value within a given range, typically represented by real numbers. In this case, temperature variation over the course of a day is continuous because temperature can be measured at infinitely many points during the day, and it changes in a smooth, uninterrupted manner. It does not jump from one value to another, but varies gradually over time, making it a continuous variable. Number 14. What is the limitation of using mathematical models in real-world investigations? A. Models always oversimplify reality. B. Models can't be visualized effectively. C. Models cannot be improved over time. D. Models are not adaptable to changing conditions. Or E. Models cannot incorporate large amounts of data. So the correct answer for this is letter A. Models always oversimplify reality. Why? So mathematical models are simplifications of real-world systems or phenomena. They abstract complex real-world situations into manageable equations or algorithms, often focusing only on the most relevant variables while ignoring others for the sake of clarity and computational feasibility. Because of this, models always oversimplify reality to some extent. This is a key limitation. While models can help make predictions and provide insights, they can capture all the complexities and nuance on the real world. For example, a model of population growth might not account for sudden changes in environment conditions or unexpected behavioral shifts into the population. This simplification is necessary to make the problem solvable, but also introduces the possibility of errors or missed factors. Number 15. What is the degree of the polynomial 3x to the power of 4 plus 2x cubed minus x squared plus 1? So is it 2, 3, 4, 5, or 6? So how will we know the degree of a polynomial? So a degree of polynomial is represented by the highest exponent of the variable. So basically, in the given equation, 3x to the power of 4 plus 2x cubed minus x squared plus 1, the highest exponent of the variable is 4. So therefore, the degree of the polynomial is 4. That's it. The answer is letter C. Number 16. Which trigonometric function is equals to sine x over cosine x? So is it tangent x, cotangent x, secant x, cosecant x, or cosine x? So we will know that later. First is that, let's have this one. We have here a right triangle with angle x. So the sides are labeled as where the opposite side is the opposite to angle x. The adjacent side is the next angle to angle x, or the adjacent side is the side next to angle x. The hypotenuse is the longest side, as you can see in the right triangle given. So from the definitions, sine x is equals to opposite over hypotenuse, cosine x is equals to adjacent over hypotenuse. So if we are going to divide sine by cosine, then we will get sine x over cosine x is equals to, what is the value of sine x? Opposite over hypotenuse, divided by the value of cosine, which is adjacent over hypotenuse. So if you are going to divide this one, we can cancel out the hypotenuse of the both parties. So the remaining will be opposite over adjacent. So opposite and adjacent is equivalent to tan over x. So you can see on the representations of the right triangle. So to sum up or to conclude, sine x over cosine x is just equal to tan x or tangent x. Therefore, the answer is letter A, tangent x. Question number 17. What is the formula for the area of a circle? Alright, we have A is equals to pi r squared, B, A is equals to pi r, C, A is equals to pi d, A is equals to pi 2 pi d, and E is equals to, we have E, A is equals to r times d. So what is the formula of the area of the circle? The answer is letter A. A is equals to pi r to the power of 2 or pi r squared. So letter B, A is equals to 2 pi r. The 2 pi r represents the equation or the formula for finding the circumference of a circle, especially when the given is the radius. So it should be C is equals to 2 pi r. That is finding the circumference of a circle using the radius. For letter C, A is equals to pi d. It is still finding the circumference of a circle when the given is the diameter. We have the pi d, but A will be disseminated and will be changed to C, which is wherein C represents for circumference. So it should be C is equals to pi d, finding the circumference of a circle using the diameter. So A is equals to 2 pi d, it does not exist, as well as letter E, A is equals to rd. Those two does not exist. So again, the formula for the area of a circle, A is equals to pi r squared. Okay, question number 18. What is the name of the theorem that states a squared plus b squared is equals to c squared? So this is very easy. Okay, is it A, Pythagorean theorem, B, Euclid's theorem, C, Fermat's theorem, D, Pascal's theorem, A, Descartes' theorem? Of course, the answer is Pythagorean theorem. That is very easy. Next question. Number 19. What is the definition of a function in mathematics? So, how does mathematics define function? A, is it a relation between sets? B, a correspondence between elements? C, a mapping between domains? D, a rule for assigning values? E, a set of ordered pairs. So, what is a function? Basically, A is not a function. It does not define a function, as well as B, which correspondence between elements. No. Mapping between domains. No. E, a set of ordered pairs. Of course not. Set of ordered pairs. No. So the answer is through elimination. It is letter D, if you are going to use elimination. So how does mathematics define a function? It is a rule for assigning values. So, number 20. How does the graph of y is equals to x squared change when x is replaced by x minus 3? So, is it A, horizontal shift left, B, horizontal shift right, C, vertical shift up, D, vertical shift down, or E, reflection across x-axis? Alright. So, let's have y is equals to x squared and y is equals to x minus 3. When x is replaced by x minus 3 in the equation y is equals to x squared, the new equation becomes y is equals to the square of x minus 3. So this transformation represents a horizontal shift of the graph. So specifically, the original graph of y is equals to x squared is a parabola that opens upward with its vertex at the origin of 0, 0. So when we replace x with x minus 3, of course, the graph shifts 3 units to the right because 3 is a positive number. So why does this happen? So in general, if you replace x with x minus h in the equation y is equals to fx, the graph of the function shifts horizontally by h units. So if h is greater than 0, the graph shifts to the right, while if h is lesser than 0, then the graph shifts to the left. So for y is equals to the square of x minus 3, the vertex of the parabola moves from 0, 0 to 3, 0. So the graph will be going to shift 3 units to the right based on the laws, which is if h is greater than 0, the graph shifts to the right. So the answer is letter B, horizontal shift to the right. Okay. For number 21, what is the difference between sine and cosine functions? Is it A, phase shift, B, amplitude, C, period, D, frequency, or E, domain? So, the sine and cosine functions are very similar, but they differ in their, of course, phase shift. Why? Okay, let's explain. The graph of the cosine function y is equals to cosine x starts at its maximum value when x is equals to 0, while the graph of the sine function y is equals to sine x starts at 0 when x is equals to 0. So this difference is a result of a horizontal shift or a phase shift. The cosine function is essentially a sine function, shifted by pi over 2 units to the left. This is why the sine and cosine graph looks very similar but are offset from one another by pi over 2. Okay. Okay, it is letter A. Question number 22. How do you find the equation of a tangent line to a curve? A. Using limits. B. Using derivatives. C. Using integrals. D. Using algebra. Or E. Using geometry. So what will you use in solving the equation of a tangent line to a curve? So the answer is derivatives. So how? So let's have the rationalization of this question. So first, let's have the equations of a line. So what do we remember about equations for lines? So they require just two elements, which are namely point and the slope. This means in finding the equation of a tangent line to a curve, which is f of x, we simply need two elements also. These are the point and the slope. So the only difference is that to find our slope, we will use the derivative. So derivatives will be used in finding the slope or the value of n. So, right, let's have an example. So suppose we are asked to write the equation of the line tangent to the curve. So here's the equation. Y is equals to x squared, where x is equals to 3. So we already have our equation. So first thing to do is that to find our point, we have to substitute the value of x, which is 3, to our function and identify the corresponding y value. So the function is f of x is equals to x squared and x is equals to 3. So f of 3 is equals to 3 squared, which is 9. So we already have our point. So the coordinates of the point is 3, 9. 3 as the value of x and 9 as the value of y. So next thing to do is we have to take the derivative of our curve to find the rate of change or to find the slope. So the derivative of f of x is equals to x squared is derivative of f of x is 2x. So we already have the derivative. So we will then swap our given x value into our derivative to find the slope at x is equals to 3. So we'll be using the derivative equation in solving our x value. So f of 3 is equal, or f of x is equals to 2x. Then the derivative of f of 3 is equals to 2 times 3 is equals to 6. So the value of f of 3 is equals to 6. Lastly, we will be substituting our point, which is 3, 9, and slope m is equals to 6, which we obtained a while ago, into the formula for point slope form and write the equation of the tangent line. So y minus y sub 1 is equals to m times x minus x sub 1. So if we have 3, 9 as a point and m is equals to 6, then we will be having it y minus 9 is equals to 6 times the quantity x minus 3, and we will obtain the value y is equals to 6x minus 18. Then we have to transfer the negative 9 and it will turn to positive 9. So basically 6 times negative 3 is negative 18 plus 9, we will have it negative 9. So the final answer is y is equals to 6x minus 9. Then we already have the equation of our tangent line to a curve. So again, the answer is using the derivatives. Next question. For number 23. What are the types of symmetry in geometry? Is it A, glide symmetry, B, rotational symmetry, C. Reflection symmetry. D. Translational symmetry, or all of the above. So you have few seconds to know what is the answer or look for the answer. So the answer is all of the above. So it means glide symmetry, rotational symmetry, reflection, and translational are all the types of symmetry in geometry. So in mathematics, the meaning of symmetry defines that one shape is exactly like to the other shape when it is moved, rotated, or flipped. So consider an example. So, when you are told to cut out a heart, okay, let's have this heart from a piece of paper. Don't you simply fold the paper, draw one half of the heart and then fold, cut it out to find that the other half exactly matches the first half. The heart that carved out is an example of symmetry. So symmetry in math, defines as the symmetry is a mirror image. When an image looks like identical to the original image, after the shape is being turned or flipped, then it is called symmetry. It exists in patterns. Okay, so we have line of symmetry. So the imaginary line or axis along which you fold a figure to obtain the symmetrical halves is called the line of symmetry. It basically divides an object into two mirror image halves. The line of symmetry can be vertical, horizontal, or diagonal. There may be one or more lines of the symmetry. So examples of symmetry, we have the line symmetry. So in one line symmetry, we have here the figure of letter A. So the figure is symmetrical only about one axis. It may be horizontal or vertical. The word or the letter A has one axis of symmetry along the axis passing through its center. So as you can see, this is the one line symmetry. We also have two line symmetry. So compare what the difference between one line symmetry and two line symmetry. So in two line symmetry, the symmetrical line has only about two lines, or the symmetry has only two lines. The lines may be vertical and horizontal lines as viewed in the letters H or X. So for our example, we have here the letter X. So if you are going to divide it into two through the two lines, you can see that it will still be mirrored to the other side. So we can see here two line symmetry at letter H. So that is an example of two line symmetry. For the next one, we have the three line symmetry. So in three lines symmetry, an example of three lines of symmetry is an equilateral triangle. Equilateral triangle is a triangle that has three equal sides. Okay, here the mirror line passes from the vertex to the opposite side, dividing the triangle into two equal right triangles. As you can see, we have line 1, line 2, and line 3. And if you fold it together, you can see that the shapes are still symmetrical to itself, even though it is divided into 3 by 3 lines. So how about 4 line symmetry? So 4 line symmetry can be seen in a square that has all the sides equal. So here in 4 line symmetry, of course, it is divided by 4 lines, and still the shapes or the divided figures are still congruent. So if we have 1 line, 2 lines, 3 lines, and 4 lines geometry, we also have, symmetry, we also have the infinite line symmetry. So in infinite line symmetry, some figures have not 1 or 2 but infinite lines passing through the center, and the figure is still symmetrical. So we have here the example. It is a circle. So a circle Even though it is divided in how many lines, the figure or the shape is still symmetrical to each other. So those are the kinds of line of symmetry. And let's have the types of symmetry. So symmetry again may be viewed when you flip, slide, or turn an object. So there are 4 types of symmetry that can be observed in the various situations. So we have, first is the translational symmetry. So if the object is translated or moved from one position to another, the same orientation in the forward and backward motion is called translational symmetry, as you can see on the figure. In other words, it is defined as the sliding of an object about an axis. This can be observed clearly from the figure given, where the shape is moved forward and backward in the same orientation by keeping the fixed axis. So that is translational symmetry. Next one, we have the rotational symmetry. When an object is rotated in a particular direction around a point, then it is known as rotational symmetry or radial. So, rotational or radial, they are just the same. So, rotational symmetry or radial symmetry existed when a shape turned and the shape is identical to the origin. The angle of rotational symmetry is the smallest angle at which the figure can be rotated to coincide with itself. The order of symmetry is how the object coincides with itself when it is in rotation. So, that is why it is called rotational symmetry. Next is the reflection symmetry. For reflection symmetry, it is a type of symmetry in which one half of the object reflects the other half of the object. It is called the mirror symmetry or line of symmetry. A classic example of reflection symmetry can be observed in nature, just like a butterfly. So if you cut a butterfly in half, the 2 parts will be the same, or it just mirrors itself. So that is reflection symmetry. Next is the glide symmetry, the combination of both translation and reflection transformations. That is what a glide reflection. A glide reflection is commutative in nature. If we change the combinations order, it will not alter the output of the glide reflection. So that is what a glide symmetry. So to sum it up, the types of symmetry are translational, rotational, reflection, and glide symmetry. So all of the above of the choices are types of symmetry. Next one, question number 24. So we have to find the roots of the quadratic equation x squared plus 4x plus 4 is equals to 0. Okay, we have to solve. So to find the roots of quadratic equation, we all know that there are a lot of ways. So for this given, based on the given, the step that we can implement on solving this quadratic equation is the factoring. So how do we solve this equation using factoring? First thing to do is to transform the equation using standard form in which one side is 0. So the equation, as you can see, is already in a standard form because the one side is already 0. Okay, let's observe the equation. And then let's factor the non-zero side. So what is the non-zero side? We have x squared plus 4x plus 4. So if we are going to factor this out, we will be having x plus 2 and x plus 2. So we already have the factors of x squared plus 4x and 4, which is x plus 2 and x plus 2. So next thing to do is to factor, or let's equate the factors to 0. So we will going to separate the two factors and equate it to 0. So x plus 2 is equals to 0. We have to transfer positive 2 to the other side, and it will become negative 2. So we have x is equals to 0 minus 2. X is equals to negative 2. The same as the other, x plus 2 is equals to 0. We have to transfer positive 2. Will become negative 2. So x is also equal to negative 2. So the answer now, or the roots of the equation x squared plus 4x plus 4 is equals to 0 are negative 2 and negative 2. So it is letter A. Okay. Next, question number 25. So for question number 25, if sine x is equals to 3/5, find cosine x. Alright. Let's have, is it A 4/5, B 3/4, C 2/3, D 1/2, or E 1/3? So let's solve this trigonometric equation. So given that sine of x is equals to 3/5, we can use the Pythagorean identity to find the cosine x. So the Pythagorean identity states that sine squared of x plus cosine squared of x is equals to 1. So that is the law of Pythagorean identity. So first step to do is to square both sides of sine x. So sine x is equal to 3/5. Then if we are going to square it, it will give us the answer 9/25. Then step 2 is to plug this value into the identity. So the identity is sine squared of x plus cosine squared of x is equals to 1. That is the identity. So we are going to substitute the value of sine squared x. We have 9/25. So let's solve for cosine x squared. So the cosine squared x is equals to 1, and we have to transfer the value of sine squared of x, which is 9/25, to the other side. It will become negative. So the equation now is cosine squared x is equals to 1 minus 9/25. So what to find the difference between 1 and 9/25, since it is a subtraction of a whole number and a fraction, we have to transform 1 into a fraction. It will become 25/25. So the equation now is cosine squared of x is equals to 25/25 minus 9/25. In this way, as we convert 1 to a fraction with a denominator of 25, it will be easier for us to subtract. Now, 25 minus 9 is equals to 16, and copy the denominator 25. So 16/25. Is it a final answer? No, because it can still be simplified. So 16/25 it can be divided into what? 16 can be divided into 4, and 25 can be divided to 5. So the final answer for this is cosine squared of x, or let's impose square root, because the given is cosine x squared, right? And 16/25 is a perfect square. So let's have square root to both sides. So cosine squared x, if it if we are going to find the square of it, it will give us cosine x. What basically it is what the problem asked for. And 16/25, the square root of 16 is 4, and the square root of 25 is 5. So The final answer is cosine of x is equals to positive negative 4/5. So, the sign of the answer, positive or negative of cosine x, depends on the quadrant in which the angle x lies. So, in sine x, in cosine x, the x or the angle x lies in where? It lies in the first quadrant. So basically, we'll be having the positive of the answer. So the final answer is positive 4/5. Okay, to continue this discussion, let's have Mr. Mark Vincent Manlunas and another 25 items on the specialization of licensure examination for teachers questionnaires. Thank you.
Next, what is the formula for the perimeter of a rectangle? A. Perimeter equals 2 times the quantity length plus width. B. Perimeter equals length plus width. C. Perimeter equals 2 length plus 2 width. D. Perimeter equals length minus width. Or letter E. Perimeter equals length times width. So the correct answer for this number is letter C. Perimeter equals 2 length plus 2 width. So let's rationalize why letter A, B, D, and E are not the correct answer. For letter A, it is not the formula for the perimeter of a rectangle because 2 times the quantity L plus W is not the same as 2 length plus 2 width. B, length plus width is not also the perimeter formula of the rectangle. Letter D also length minus width. And letter E, perimeter equals length times width. That's the area of a rectangle. Next, find the perimeter of a rectangle with length 6 centimeter and width 4 centimeters. So, as we all know that the formula in finding the perimeter of a rectangle is 2 length plus 2 width. So let's plug in 2 length plus 2 width. So as we all know that length is 6 centimeters, so that's 2 times the quantity 6 centimeters plus its width, which is 4 centimeters. So 2 times 4 centimeters. So the perimeter of a rectangle is equals to 2 times 6, that's equals to 12 centimeter, plus 2 times 4, that's 8 centimeters. So 12 plus 8, that will be equivalent to 20 centimeters. So our answer for this number is 20 centimeters. That's letter D. Next, which of the following symbols represents the logical operation AND? So our answer for this number is letter B. That's the symbol for the logical operation AND. So let's rationalize why letters A, C, D are not the correct answer. So letter A, that's the logical operation for OR. And the letter C, that's the logical operation for NOT. And for letter D, that's the logical operation for if and then. Next number. In set theory, what is the term for a set that contains no elements? A. Universal set. B. Singleton set. C. Empty set. D. Power set. Or letter E. None of the above. So our correct answer for this number, or our clue word, is no elements. So therefore our answer is letter C. Empty set. So let's rationalize why letters A, B, D, and E are not the correct answer. So for letter A, universal set, it contains all objects of the other sets or elements including itself. Letter B, singleton set, it contains only one element since it's single. Letter D, power set, is the set of all the subsets of the set including the empty set and set itself. While letter E, none of the above. So that's why our answer is letter C, empty set. Next number. What is the name of the set operation that combines all elements from two sets? A. Intersection. B. Union. C. Difference. D. Complement. Or letter E. None of the above. So our answer for this number is letter B. Union, since it combines all elements from the two sets. So let's rationalize why letters A, C, D, and E are not the correct answer. So for letter A, intersection, it is the set contains all the common elements of both sets. While letter C, difference, it is the set of all elements that are in one set but not on the other sets. While letter D, complement, it is a set of all the elements in the universal set that are not in the given set. And letter E, none of the above. So our answer for this number is letter B, union set. Next, consider the sets A is equals to the set of 1, 2, 3, and set the B, we have 3, 4, 5. Which of the following represents the intersection of sets A and B? A, set 1, 2, 3, 4, 5. B, set 1 and 2. C, set 3. D, set 4 and 5. Or E, none of the above. So as we all know that intersection of sets is the common elements of both sets. So therefore, it only requires common elements of the two sets. So here, our example, we have set A, we have 1, 2, 3, and set B is 3, 4, 5. So the common element of the two sets is only 3. So therefore, our answer for this number is letter C, set 3. Next, a die is rolled once. What is the probability of rolling an even number? A, 1/6. B, 1/3. C, 1/2. D, 2/3. And E, none of the above. So, as we all know that even number are numbers that is divisible by 2. So, a dice has 6 numbers. We have 1, 2, 3, 4, 5, and 6. And the only 3 even numbers are 2, 4, and 6. So our answer for this one will be 3 out of 6. So 3 over 6. And 3 over 6 can be simplified. So our answer is 1/2. So the correct answer for this number is letter C, 1/2. Next, what does P represent in the simple interest formula I equals P times R times T? So, as we all know that the formula in finding the simple interest is I equals PRT. So therefore, our correct answer for this number is letter A, principal, in which the principal, it is the initial amount of money borrowed or invested before interest is applied. So let's rationalize why letter B, C, D, and E are not the correct answer. So profit, so while interest can sometimes be considered as profit, but the term P is specifically related to principal. And then for the payment, it is the total amount repaid. And for the percentage, it relates to the rate in the formula or the R. And as for letter E, premium, it is not unrelated to simple interests. Next number, what type of assessment provides immediate feedback that helps both teachers and students adjust their strategies during the learning process? A, formative assessment. B, summative assessment. C, diagnostic assessment. E, D, norm reference assessment. Or letter E, criterion reference assessment. So our keyword here is provide immediate feedback. So our answer for this number is letter A, formative assessment, where it offers immediate feedback to the both teachers and students to adjust strategies during the learning process. So let's rationalize why letters B, C, and D and E are not the correct answer. For summative assessment, it occurs at the end of the learning and do not offer immediate feedback. And for letter C, diagnostic assessment, it identifies prior knowledge or gaps but are not focused on real-time adjustments. And for norm reference assessment, it compares students' performance to a norm group and does not involve immediate feedback. And for the criterion reference assessment, it measures students' performance against specific criteria but is not focused on real-time adjustments. So our answer for this number will be letter A, formative assessment. Next, which type of assessment is used at the end of a term? A, diagnostic assessment, B, formative assessment, C, criterion reference assessment, D, summative assessment, or letter E, placement assessment. So our keyword here is at the end of a term or unit. So the correct answer for this number is letter D, summative assessment. So let's rationalize why letter A, B, D, and E are not. A, B, C, and E are not the correct answer. So for letter A, diagnostic assessment, it is used at the beginning to identify prior knowledge or learning gaps. And for letter B, formative assessment, it conducted during learning, not at the end. And for criterion referenced assessment, it can be used for end of a term evaluations but isn't specific to cumulative learning. And for letter E, placement assessment, it is used to determine the appropriate starting level for a student, not for end of term or unit evaluation. Next, a warehouse has 180 items that need to be packed into boxes such that each box contains an equal number of items. So which of the following box sizes would ensure there are no leftover items? So our keyword here is no leftover items or remainder. So meaning to say, each box must contain equal numbers. So A, 19, B, 30, C, 13, D, 14, E, 25. So let's identify which number can be divided into 180 equally. So 19 is not an answer because it can't divide 180 evenly. And for letter C, 13, it does not also divide 180 evenly. And 14, it does not also divide a 180 evenly. And for letter E, 25, it does not divide 180 evenly. So our answer for this number is letter B, 30, because 180 divided by 30 is equals to 6. Next number. In logic, what does the symbol this one represent? A, conjunction, B, disjunction, C, negation, D, implication, or letter E, none of the above. So our answer for this number is letter C, negation. It represents the symbol shown above, and it represents not. So let's rationalize why letter A, B, D are not the correct answer. For letter A, conjunction, the symbol for conjunction is arrow facing upward, and it represents and. For disjunction, its symbol is facing downward arrow, and it represents or. And for letter D, implication, the symbol for this is facing to the right arrow, and it represents if and then. Next number. Solve for x. X squared plus 4x plus 4 is equals to 0. So simply, let's factor this one into square of binomial. So that will give us the answer of x plus 2 squared is equals to 0. And then after that, we will going to square root both sides so that 2 will be cancelled out. So our answer is x plus 2 is equals to 0. And then let's add both sides by negative 2. So x, our answer will be negative 2. So ax equals negative 2, bx equals negative 4, cx equals 0, dx equals 2, and de is x equals 1. So our answer for this number is letter A, x equals negative 2. Next number. Solve the system of equations. X plus y equals 4, x minus y equals 2. So for this one, we're going to eliminate y since they have different signs. So x plus y equals 4 plus x minus y equals 2. That will give us the answer of 2x equals 6. And then we will going to divide both sides by 2. So the correct answer for our x is 3. And then let's substitute 3 any of those number that you want. So I will going to substitute 3 into x plus y equals 4. That will give us 3 plus y equals 4. And then let's add both sides negative 3. So y is equals to 4 minus 3. So y is equals to 1. So our answer for this number is x equals 3 and y equals 1. So our answer is letter A. Next number. What is the formula for the sum of geometric series? A, S is equals to A over 1 minus R. B, S is equals to A over the quantity 1 plus R. C, S is equals to A times the quantity 1 minus R. D, S is equals to A times the quantity 1 plus R. Or letter E, S is equals to A plus R. So our answer for this number is letter A. So that's the formula in finding the sum of geometric series. S is equals to A over quantity 1 minus R. Next number. Which of the following best describes the mean of a data set? A, the middle value when the data is arranged in order. B, the most frequent occurring value in the data set. C, the sum of all values divided by the number. D, the difference between the highest and the lowest values. Or letter E, none of the above. So our keyword here is mean of a data set. So our answer for this number is letter C, the sum of all the values divided by the number of values. So that's relates to mean. So let's rationalize why A, B, D are not the correct answer. For letter A, the middle value when the data is arranged in order, so that's related to median. For letter B, the most frequent occurring value in the data set, it refers to the mode. And the difference between the highest and the lowest values, it refers to the range. Next, given the equation of the curve 3x squared plus 2x minus 5y plus 7 is equals to 0. Determine the curve. A, ellipse. B, circle. C, parabola. D, hyperbola. Or letter E, cone. So our answer for this number, or our keyword here is 3x squared. And it has only 1 squared. So our answer for this number is letter C, parabola, since it fits a single squared variable. So let's rationalize why A, B, D, and E are not the correct answer. For letter A, ellipse. Ellipse requires both x squared and y squared terms with the same signs. with the same sign. So ellipse is not the correct answer. For letter B, circle, it requires equal coefficients for x squared and y squared. And for letter D, hyperbola, it requires opposite signs for x squared and y squared. And for letter E, cone, it does not related for the to the conic sections. For the 4 conic sections. Next number. What is the derivative with respect to x of quantity x plus 1 cube minus x cube? So first thing to do is let's expand the quantity x plus 1 cube. So our answer for this will be x cubed plus 3x squared plus 3x plus 1 and then copy minus x cubed. So our answer for this will be x combined like terms. Our answer for this will be 3x squared plus 3x plus 1. So the derivative of 3x squared plus 3x plus 1 will be 6x plus 3. So our answer for this number will be 6x plus 3, letter D. Next, a gardener is arranging flower beds such that each bed can be filled with 24 flowers, and they have a total of 120 flowers. How many flower beds can they create? A, 5 beds, B, 3 beds, C, 7 beds, D, 4 beds, or letter E, 6 beds. So our first thing to do is we will just simply divide 120 by 24. So 120 flowers divided by 24 flowers, our answer will be 5. So our answer for this number is letter A, 5 beds. Next, what is the primary benefit of integrating technology into mathematics teaching and learning? A, it reduces the teacher's workload. B, it allows for the automation of grading. C, it provides dynamic opportunities for interactive and individualized learning experiences. D, it replaces the need for textbooks. Or letter E, it improves students' memorization of mathematical formulas. So our answer for this number will be letter C, it provides dynamic opportunities for interactive and individualized learning experiences. So let's rationalize why letter A, B, D, and E are not the correct answer. For letter A, it reduces the teacher's workload. It is a benefit, but not the primary one. Letter B, it allows for the automation of grading. It is useful, but not the main advantage. For letter D, it replaces the need for textbook, which is incorrect. And letter E, it improves students' memorization of mathematical formulas, which is also incorrect. So our answer for this number is letter C. Next, in evaluating an interactive app for learning fractions, which of the following criteria is most important? A, the app is free to download. B, the app provides step-by-step explanations or process that support conceptual understanding of fractions. C, the app has vibrant animations and music. D, the app includes a wide range of quiz questions. Or letter E, the app can be used without any teacher input. So our answer for this number will be letter B. The app provides step-by-step explanation or process that support conceptual understanding of fractions, which is the key for learning. So let's rationalize why A, C, D, and E are not the correct answer. For letter A, the app is free to download. It is useful, but not the most important. For letter C, the app has vibrant animations and music, which is engaging but secondary. For letter D, the app includes a wide range of quiz questions. It is helpful but not the main focus. And for letter E, the app can be used without any teacher input, which is limits guidance. Next, why is it important for teachers to carefully evaluate technology tools before using them in mathematics instruction? A. To ensure that students are entertained during lessons. Letter B. To make sure that tools align with educational standards and learning objectives. Letter C. To select tools that require minimal internet access. Or letter D. To avoid spending too much money on tools. Or letter E. To select tools that are easy to operate without students' input. So our answer for this number will be letter B. To make sure that the tools align with educational standards and learning objectives, which ensures educational relevance. So let's rationalize A. C, D, and E are not the correct answer. For letter A, to ensure that students are entertained during lessons, which is incorrect. For letter C, to select tools that require minimal internet access, which is useful but not the main focus. For letter D, to avoid spending too much money on tools, important, but this is secondary. And for letter E, to select tools that are easy to operate without student input, which is incorrect. Next number. Research in mathematics education suggests that technology can enhance learning if A. Students are required to use it daily. B. Teachers receive training on how to integrate technology effectively into their lessons. C. Technology replaces all traditional teaching methods. D. Technology is used only for assessments. Or letter E. Technology is used to reward students after they complete their task. So our answer for this number will be letter B. Teachers receive training on how to integrate technology effectively into their lessons, which is training ensures effective use. For letter A, C, and D, and letter E, it is incorrect. Next, the following are common creative thinking abilities except A. Improvising, B. Brainstorming, C. Innovating, D. Elaboration, or letter E. Conformity. So our answer for this number is letter E. Conformity, which is opposes creativity. So let's rationalize why A, B, C, and D are not the correct answer. Because letter A, improvising, it is a creative skill. Brainstorming, it is a creative process. Innovating, which is a creative activity. And for elaboration, which is a creative strategy. Next, for the last number, behavioral terms like reconstruct, generate, design, devise is under what categories of cognitive domain? A. Remembering, B. Applying, C. Analyzing, D. Evaluating, or letter E. Creating. So our keyword here are reconstruct, generate, and design. So these terms are related to creating. So our answer for this number is letter E, creating, which involves generating and designing. So let's rationalize why A, B, C, and D are not the correct answer. Because letter A, remember, it involves recalling. For letter B, applying, it involves using our knowledge. And for letter C, analyzing, it involves breaking down of ideas. And for letter D, evaluating, which involves judging.
So that's all for our 50 questions in general education, professional education, and specialized education. Thank you for listening, and I hope you learned something today.